2005 Impacts and Collisions. We have three identical smooth spheres, P, Q and R. They're lying at rest, very important. Smooth horizontal table, centers in a straight line. Q is between P and R. Q is between P and R. So here we have my three spheres. Sphere P is projected towards Q with initial speed 2. Then P collides with Q, and then Q continues on and collides with R. We have E, the coefficient of restitution, as 3/4. So let's see, we're asked to show that P strikes Q a second time. So its velocity must be greater. This velocity of P must be greater than the velocity of Q for it to strike it a second time. So the principle of conservation of momentum, m1u1 plus m2u2 is equal to m1v1 plus m2v2. And we have Newton's experimental law, which we write as the change in their final velocities. So v1 minus v2 over u1 minus u2 is equal to minus e. These are the two formulas we always use in this question. So let's set up P and Q here to hit each other. P and Q. We have U is equal to 2. Q is at rest. Masses are the same. So we don't know V1 and V2. Let's find them. The m's are all the same. We'll leave it in for now. M times 2 for P plus m times 0 for Q is equal to mv1 plus mv2. Dividing by m, we're going to get v1 plus v2 is equal to 2 for our first equation. Then we can apply them to this. Newton's experimental law, v1 minus v2, which are our unknowns, over 2 minus 0 equals minus 3/4. So we get 4v1 minus 4v2 is equal to minus 3 by 2 is minus 6. If we multiply this one by 4, we'll be able to cancel our v2's. So we're going to get 4v1 plus 4v2 is equal to 8. So we get 8v1 is equal to minus 6 plus 8, which is 2. So v1 is 2 over 8, which is equal to 1 over 4. So that's the velocity of P. So this is P. The velocity of Q is v2. v2 is equal to 2 minus v1 from this equation. So v2 is equal to 2 minus 1/4, which is 1 3/4, which is equal to 7 over 4 if you want to write like that. And we'll put in our units, meters per second. So I have the speed of P, and I have the speed of Q. We're asked to show that P strikes Q a second time, so Q is going to go in this direction, strike R, and we have to show that P's speed at that point is greater than Q's speed, so it catches up with it. So now we're looking at Q and R. So we set up the same things here. We have Q has a speed, R is at rest. So we're going to have, if we divide by m, we're going to have this speed of Q, which is 7 over 4, is equal to, it's the same as this equation here. That's going to be equal to, if we call them v3 and v4, we can just call them v1 plus v2 again. So we have Q and R. And then for my Newton's experimental law, I have 7 over 4 minus, v1 minus v2 on top. v1 minus v2 over 7 over 4 minus 0 is equal to the same e, minus 3 over 4. So 4v1 minus 4v2 is equal to minus 21 3 times 7 over 4 is 21 over 4, so minus 21 over 4. So now I want to cancel my V2, so multiplying the top one by 4, I have 7 over 4 by 4, which is 28 over 4. That's going to be equal to 4v1 plus 4v2. Adding these two together, we get 8v1 is equal to 7 over 4. These two added. So we get v1 is going to be equal to 7 over 32, or 7 over 4 times 8. So therefore v2, well, we don't need v2 actually, we just need the speed of q. And we're asked to show that p strikes it again, so the velocity of p after it strikes q the first time is 1 over 4, which is equal to 8 over 32. And the velocity of q is 7 over 32. So we can say that the velocity of p is greater than the velocity of q. Therefore, strikes the second time.